Hello guys, and welcome to a new video. In this video I will try to show you how to verify after you finish the schematic, how to compile the project and to check for errors if this will appear, and how to run design rule check for your layout. And after that we will generate the manufacturing files in few ways. For the beginning, we will go to our main project and we will press right click and we will try to validate our project. If this window with message will appear, this means we have some warnings or some errors. In our case, we have an error here regarding these output pins that are connected together, and maybe sometimes this type of errors cannot be avoided only if we modify a little bit inside of the symbol. And here for this integrated circuit, for example, this pin, it's an output, and because we have more circuit like this, all outputs are connected together. But if we know about this problem, this not represents a big error, and sometimes we can turning off from the matrix. And for turning off this error, because this is not a fatal error, and with this error our design it's not affected, for this we should go to project options, and here we have this connection matrix, and we will look for the output pin, and here we have the matrix output pin versus input pin, output pin versus input output pin, and output pin versus output pin. And here now we have selected to signalize an error for this type of connections, and we can change it to fatal error, but in our case we'll put to no report because we know about this error. If we want to have no error on the compiling, we will do like this, and we will exclude this error from our matrix, but only for this demonstration I will do this. In general, sometimes we are not able to solve all of the errors from the symbol, and we should take this path. And after that we will press OK, and now we will try to validate again our project, and we will open our panel with messages, and now as we can see at the end of this compilation, we have this info: compile successful, no error found. And we still have some warnings, and all of the some of the warnings are also related to input output pins and output pin object, and some of the errors are regarding to grid, and we will check this. We have this net label which is not on the grid, so I will select it, right click and align to grid. And now when we compile again, some of the warnings disappear. As you can see, we still have one more here. No driving source, no driving source. Some of the components are from the server, and when you use components from other server and the server is not added in your component library and are not installed, you will receive some errors like this. But for the moment we can let it like this, because for our demonstration it's okay. Our project was compiled and we don't have any errors. After that, we'll move to our layout and we will try to compile also this error. In general, for the layout, we have some special rules, and to check these rules, we should go to this design tab, rules, or simply press DR from your keyboard. And now we can check we can check some rules from electrical side. We have this main clearance. So for all components, our main clearance it's 0.127. We have here possibility to create custom rules for short circuit, or to avoid some components from these rules. We can create here custom queries, and in this way we can exclude some of the affected components from this short circuit rule. We have some rules from unrouted net. So if some of our connections remains like this unconnected, this will be detected. And we still have here other rules related to width. So we have here some preferred width, it's 0.254. So here is the minimum and the maximum width allowed in our design. We have also some rules related to our vias, and in our case we have only one via. And here we have some rules related to manufacturing. So some of the rules are related to the silk. It's the text from our board, or we can call the ref designator, or the text from the component. So this is the main tab with the rules. Now we will try to compile our project, and for this we should go to tools and execute design rule check. We can increase here the number of violations, because sometimes when we have a big design, if we let only 500 violations and our design detects 1000 violation, the design rule process will stop at 500. So here we can put something like this, 10,000. And always this box must be checked, because if we unchecked and we press OK, when we execute the DRC, we will not receive anything, only a message here on the right side. And for this you have to check everything one by one, and it's not so easy. So if we will go back to this tab and we will select this report file, after we will execute this DRC design role check, we will have a report like this, and here it's very easy to check the violation. So in our case we have 126 violations, and now we will go to see what are exactly our violations. So we have some violations related the minimum solder mask sliver. So this represents the distance between this outline and the text from here, and sometimes you can check the violations hitting from your keyboard Shift plus V. So you can go over the violation, and only if the violations it's with green, when you hit these combinations, this shortcut, your violation will be described in detail. So in our case, we can check this from rules, because this is not so important. So we can go to manufacturing, minimum solder mask sliver. So here we can put something like this. So in our case, we don't take care about this. And now press OK. And when we execute again the DRC, now we solve all the violations. Only in this special case we put the clearance almost zero, because sometimes the violations are not so critical, but please be aware and take care always regarding the other violations, because some of them are very important, and not always is the best solutions to turning off. So after that, if your project was compiled successful, you can generate the fabrication file for the manufacturer. And for this we have more possibilities. One of the possibilities is to go directly to file, and here you have these fabrication outputs, and we will go to the Gerber files. One pop-up window will appear, and here we will select the inch, and the format is 2.4. And for layers, in our case we have only 2 layers. We will select the top overlay, top paste, top solder, top layer, bottom solder, bottom paste, and bottom overlay. And we have the shape of the board is the keep out layer. Sometimes some company use different mechanical layers for the board outline and for the board shape. We go to drill drawing. We will select this plot all use drill pairs, and for the other options this will remain the same. And after that we simply press OK, and now our Gerber files are generated, and Altium offer you this Camtastic file. It's a Gerber viewer, and if you don't like it to check your PCB with this Camtastic file, you can simply download it a ViewMate from Pentalogics, and there you can import your gearboard and check if everything is okay. But if you simply want to use this Camtastic for checking the gearboard files, you should go here to this tab, Camtastic, and here you have all the layers. And for example, if you want to turn off some of them, for example this bottom layer, you can simply go here and turning on and off one by one. So if you want to check only the top layer, we can turn off all the other layers. And now we can simply check for the top layers if our layout looks okay, or we still need some to do some modifications, or maybe sometimes the clearance is not enough, and we can simply check this in this view of the gearboards, and we can simply let only the components and the paste and the top overlays. For example, if we want, we can check if the bottom layers are okay, and you can go through them one by one, and in this way we are sure our design it was how was intended to be. Another file that it's required for the manufacturer, it's the file called nc drill file. This file contains the details regarding your holes and drills from your board, and for this you can simply go back, select the PCB file, and go to file, export, fabrication outputs, and here we have this NC drill files. Our setup will be the same, inch and 2.4, and only simply press OK. And now our NC drill files were generated, and now simply press OK. As you can see in this Camtastic file, our information contains only details and descriptions regarding the holes, and for this you have only this text file that contains all the details regarding our board drills and holes. The third file that it's required for the manufacturer at the beginning, it's this pick and place file, and for this you should go to assembly outputs, and here we have this pick and place file. You can simply select, and here you can create your own preference if you want to have a different order, or your pick and place file must contains different details. You can simply add or delete it from these columns, and if you simply select OK, one file will be generated, and for this we should go directly in the project, press here explore, and here we have this project outputs, and here we have this pick and place, and we will open it, and as you can see, here we have some details regarding your components and their position to the board. And here are the information regarding to the rotation, and all of this information will be inserted in the pick and place machine, and all the process will be done automatically, and the machine will place all of the components one by one at the proper coordinate. I think this was an old file, but we have our last generated file here because uh, our dimensions was in the millimeters, and here we have also the details regarding the type of the footprints and where the component will be placed, on the top or on the bottom layer, the position, the coordinate for x, y axis, and here it's the rotation and the short description of each component. Another possibility to create these manufacturing files is to create an output job file. We have this possibility: file, new, output job file. I already have one here created, and when you open a output job file, something similar with this will appear, and here on the top side we have possibility to choose the placement variant if we have a project with different placement variant, and in our case we have no variations here, and we can customize each of these tab with our preferences. For example, we have some details regarding the documentation outputs, and here we have only PDFs that contains schematic prints, details regarding our PCB. Now, and here on this 3D top and bottom, we have description with 3D model for top and bottom. I will select this Microsoft Print to PDF to make a simple demonstration, and I will took 4 of these ones. So in this way we can create a structure and define our own structure. At the end, with only one click, we can generate all the necessary files for the manufacturer, and it's more easy to create an output job and to to use also for all of your project. So we will check how this will looks only with this preview. And as you can see, we have 4 pages. One page contains the schematic, the other contains our board with layers, and other two contains the 3D view of our board. So if we want to generate also some assembly drawings, we have here the assembly outputs. So we will check how it looks our assembly drawing. So we have this description and the placement of components inside of this assembly, and here we can generate the pick and place, and we can configure the same like previous. Here we have the fabrication outputs and Here we have the Gerber files. Here we have the NC drill files, and here we have the bill of materials and also the 3D model of our board, the step file. And in this way, we can create our custom output job, and we can generate all of the files with only one click. For example, if you want to generate only PDFs, we will select here on the right side the output containers to select all of the PDF file. Here we can select the Gerber files, the boom files, and we can simply add the new folder structure if you want. And I think these are the all files that are required when you want to request an offer from a manufacturer or from an EMS manufacturer. You can simply generate your Gerber and your files, and you can give them this file to give you a quotation, a price quotation for this. And after that, you can generate all the other files, the bill of materials, and you can order the components and to build your first board prototype. I hope this information was very helpful for you, and I also hope we will meet in the next videos. Bye bye.